Hi guys, good evening.
Good evening, sir.
Good evening, bro.
Very good evening. So our today's topic is SQL index. SQL index. What index will do is indexes in SQL server data structure
SQL index. The index is a SQL database that are also associated with the
that are associated with the
tables.
Okay. So indexes in SQL server are the data structures that are associated with the table. Guys, please. Okay. So what indexes will do is indexes okay help us in increasing the
Performance.
performance of a query while doing search operation. While doing search operation. Search operation means what is a search operation? Suppose
retrieving some data.
Where
select star from EMP where DEP ID equals to 1001. So what are you trying? What are you doing here?
where condition?
So if you do select star from EMP, what it will give? It will give us the entire data from a table. But when you are running this query, what would be the output? So from out of all the records, it is searching for only specific records. It is performing some searching operation, right? So while performing a search operation, it will give us an faster performance. So here, in employee table, have you created any index so far? How to check?
Help
Index.
employee.
Okay. If the object employee does not have any indexes. Object employee here does not has any indexes. So even if you okay, so you can see here as well. Okay. So if you want to check from the object explorer, go to the database or database is sample and in the table is employee. So here you have an option called indexes. Okay, if you see, if you create any indexes, you can able to see here. Or sp_help index will give us the indexes. Okay, we'll come there, not a problem. So if I created a table without any indexes, if the table with any indexes is called heap table. The table without any indexes is called heap table. So which means, so suppose let's say whatever the data that you are inserting into a employee table, how you are inserting, in the same way the data will be get loaded into the database. The same way it will load. Okay, let's see. So what is the difference is, I'll check, I'll let you know. For now, keep this here. Okay. So the employee table, what we have already created, is having indexes or not?
No, sir.
No indexes created on this table, right? So
Yes.
if there is no indexes on this table, then what we call this table?
Heap table.
Heap table, right? So if before running this query, so heap table, so when you are running this query, so I'm just getting this data. So how it is performing is, how the SQL engine will perform?
First
The
go
search
to
operation.
employee table. First it will go to employee.
Row by row.
Row by row it will search. Okay. So how many records are there in the table?
14 records.
So how the SQL engine will perform the search operation? Okay. Table. Okay. So it will take two. Either it will perform table scan or it will perform index scan or seek. Okay. When SQL engine will take a table scan, when SQL engine will take a index scan or index seek, that we'll discuss. So whenever you have created a table without indexes, on the table, if you are performing any such operation, then by default it will do table scan. Table scan in the sense, it will go and search each and every record in the table. Okay. So let's say, so before, this is my query. Before executing my query, I just wanted to check which execution plan it has taken. See here, display estimated execution plan. See here, you have a option is there. So if you click, what it is doing, what it is performing,
Table scan.
table scan it is performing. When I say table scan is in the sense, what it will do is, it will search record by record, and if it found 100, if it found 1001, then it will print the record. So if suppose in my table I have 1000 records, it will perform 1000 operation. See, if I keep the cursor here, so it is giving all the details. See, if you see estimated number of rows to be read, how many it is saying?
14.
14 rows. In the table, how many rows we have?
14.
14 rows we have. So which means the current query is searching all the records. Though all the records are not belongs to 1001, it is searching for all the records, whether this record is department ID is 1001 or not, this record ID 1001 is not, and so it is scanning all the records. So that's why we call it as table scan. And how many, see, next, estimated number of rows for all execution, 3 rows it is written.
3.
Okay. So let's say, got it right, table scan. So it is performing. If you have not created any index on a table, by default it will perform table scan. If you want, you can check any column you can take from the table, where department ID equals to this employee ID I am taking, EMP ID equals to some, I'm just taking this. Okay, one record, sorry. 6678 32. Okay, select the display execution plan for one. See, how many employees would be there with this employee ID?
Only
1. So
One.
it will return only one record, but how many records it is reading?
14.
14 records.
And how many records it is reading all executions? After
One.
scanning all the records, how many records it is returning?
One.
Only one record. So even though it is returning only one record, it is taking a table scan. Suppose if you go for job name equals to manager, select the display executed plan. It is performing table scan. And how many records were there with the manager? 3. If you want, you can select only 3 records, right? That's what we are seeing in the stats or not. Whatever the search operation you are performing, irrespective of the number of records it is returning by the SQL query, it is scanning all the records in the table or not.
Yes, sir.
It is scanning. So, which means here we have only 14 records. That's why we are getting a result is very fast. Okay. Suppose in my table I have a 1 lakh record, and out of which my query should retrieve only 100 records. Then
So much time, sir.
it will take so much of time, right? Since we don't have any plenty of information here, so the query is running faster, even if you create index or not creating an index. But how you can see the query is performing a table scan or index scan? So by seeing this, we can come to know. Okay. Okay. Next. So let me create one index on top of this table. Okay. Create index. I'm just creating a clustered index on table. What is the table?
Employee.
On which column we need to create an index? Tell me. Now I want to create an index. So on which column I need to create an index?
Employee.
Column is column having unique values and not null values.
So here you need to see. So which is the column we frequently used in the where class or in the join class, join operation? In the join will map, right? A dot employee equals to B dot, A dot department equals to B dot department. Like that, we will be doing some matching criteria, right? So whatever the columns that you are frequently using in your where class, on that column, you can create a index. You preferable to create an index. If you are creating an index on all the columns, that will decrease the performance. Okay, here. So I just wanted to go for employee ID for now. Okay, employee ID. Sorry, here I have not given index name. IX CLI in a sense cluster index. Okay, employee ID. So this is, you can give any name, not a problem. So IX means index and CLI is index clustered index and the column is employee ID. So for better reading, I just gave that name. Okay. Now the cluster index is created. Okay. If you want to see the index is created or not. Okay. So if you see, cluster index is created or not?
Yes, sir.
Okay. Now run the same query. If I run this query, what will happen? See, estimated executed plan. What it is happening?
Clustered index scan.
Cluster indexes scan. Okay. Next, if I run the executed plan for this, what it is? Cluster index seek. But if you run this, what happened?
Clustered index scan.
Scan. You are seeing. Okay, if you click on this department ID, just see.
Scan.
So the column on which you have created a cluster index, which is performing a cluster index seek, the other if you are using the other columns in the table other than the indexed column, it is performing a cluster index scan. Okay, when it is performing a cluster index scan, how many records it is reading?
14.
14 records.
14 records, the entire it is reading. Why? We created a cluster index on
Employee
employee ID, not on the department ID.
department.
Okay, so suppose if you run this estimated executed plan, see now, number of rows to be read, how many?
1.
It is reading only one, right? And how many it is execution it is resulting? 1, which means how many records we want to retrieve, that many reads only happening on the table or not?
Yes, sir.
So which means it will increase the performance or not? So I have a table, in my table 1 lakh records are there. If you are not creating an index and you are searching for, if you are running a query on top of that table and for specific data, so what it is doing, irrespective of the number of records that SQL query is returning, it is searching all the records in a table. But if you create an index, cluster index on the table, what it is doing is, on whatever the column that you have created an index, if you are using that column in a in searching, so that will perform index seek, and how many records that SQL query is returning, only that many reads will happen. Only that many reads will happen. Got it or not?
Yes.
Any question? See, sorry, here it is, if you are not creating any index on a table, it is performing a table scan. Though you have created index and you are using non-indexed column in the, see, on the first, in our first scenario, what we did, we have not created any index on the employee table, right? And when there is no index on table, if you are searching for the data, so which scan it is performing?
Table scan.
Table
Row by
scan.
row.
Okay, table scan, which means it will read all the rows from a table. And next, so now I have created a cluster index on table. If I create an index on the table, which scan should perform?
Cluster scan.
Index scan or index seek should perform. When index scan will perform, when index seek will perform. So on a table, if you have created the cluster index, and if you, whatever the column, see here, cluster index is created on a employee ID. If I use this employee ID in the where class, then it will perform index
scan.
seek. Whatever the column that you are used for creating a cluster index, if you use that column in the where class, then it will perform index seek. And if you are on the cluster indexed table, if you are using non-indexed column, this is non-indexed column or not? Job name.
Sir.
Yeah, because you have not mentioned this column name in the index creation. So this is though the table is an indexed table, but you have this column is not included in it. So that's why it is saying index scan. Index scan. Okay. See, suppose here what I am doing is employee ID equals to this, and if I write one more condition over here, job name equals to manager. If I run this query, check estimated execute plan.
Index seek.
Cluster index seek. Okay. Got it, right? So when the table scan will perform and index scan will perform. Okay. So now, generally, so the index is like something like how we have an index in our textbook. If you don't have an index in a textbook, So if I ask you to search for one particular topic, then what you will do?
Page by page, we will see.
What you will do? You will go page by page
Page
and you will
by
search for the topic that you want. Right or not?
Yes, sir.
Suppose if you have an index, then what if I ask you to search for a topic, then what you will do?
We will see the index
That's
and we will see the page
First you will go
number.
to the index page, right?
Yes, sir.
Yes, sir.
You will go to the index page and you will take the page name, you will search for a topic and whatever the key, which is key is nothing but a page number. Against it, you will directly go to there. Right or not? So which is the best way? If you create an index, the performance is better, or if you're not creating index, the performance is better.
Creating index is better, sir.
Creating index is a will give us the better performance. Okay. There are two types. We have multiple types, and I am just here. I am just explaining you two types of indexes in SQL Server. Okay. There are two types of indexes. One is
Cluster.
clustered index. The other one is non-clustered index. Okay. What the cluster index will do? It will
Puts in clusters, sir.
physically sort the data and will store. It will physically sort the data and will store in the database. Okay. And next, it will only one clustered index can be created on a table. Only one cluster index can be created on a table because as the data, ఇక్కడ ఏం చెప్పానండి, what I told?
Physically
Will
sort.
physically
Sorted data.
sort the data. Okay, and will store. First it will sort the data and then it will store the data in the database. So only one cluster index can be created on a table. Why? Because we can sort the data in only one order, right?
Yes, sir.
Either you can sort the descending order or ascending order. Suppose if you are if it is allowing a multiple cluster index, so one cluster index is trying to sort the data in one order, and the other column is other cluster index is trying to sort the data in another order. So which will never happen, right?
Yes, sir.
Yes, sir.
So that's the reason why we can't create multiple cluster indexes on a table. Okay, only one cluster indexes can be created. Okay.
Can you repeat it again?
Sorry.
Can you repeat it again?
See, suppose I have created here. You have seen an example, right? I have created a cluster index on employee ID. So what a cluster index will do? It will physically sort the data and will store into the database. Okay. So what it will do is, suppose if there is a table and I'm just trying to insert the data in a random order. So what it will do is, the cluster index will do is, before loading the data into a database, it will check the order of the data. If it is not in a proper order, it will rearrange the data in a particular order and then it will store. Okay. So let me show you an example here. Okay. You will get a clarity. Create table. I'm just creating on temp table and some temp s number int s name varchar of. Okay, I'm just creating on temp table. Table is created. Okay. Insert into temp. S number is 1. S name is some Krishna. Okay. I need to keep the keyword values. Next. 5. Some Raghu. Okay. 4. Raju. Okay. Make it 3. Now 4. Ramu. Okay. I'm inserting this data into this table. Now do select star from temp. Have we created any indexes on this table?
No, sir.
So which means this table is what is this table? We call it as
Heap table,
heap table. So how the data is inserted?
random.
The same way that we have inserted here. Whatever the order that we have inserted in the using insert statement, the same way it is the same order it is there, right?
Yes, sir.
Okay. Now I am creating a cluster index on this table. Create clustered index ix underscore s number on temp. Create cluster index name on table of s number. I'm creating a cluster index on this table. Okay, now cluster index is created. Now do select star from emp temp. What happened?
Order changed, sir.
Order change. So why?
Ascending order.
So the functionality of the
Sorting
cluster index is
cluster.
it will physically sort the data on what basis it will sort? On S number it will sort. Here what you have mentioned, you have not mentioned means it is a automatically will take ascending order. So in ascending order it has arranged the data in data right and stored. Okay, whatever I have mentioned here, the first statement. It is physically
sorted
sorting and store the data. Okay, let me now insert into temp values to some. I'm just giving this like some name. Okay, if I insert this record, where this should locate? It has to add at the end or it has to add after one.
After one.
Came right?
Yes, sir.
So every time you are inserting a data into a cluster index table, so what it will do is it will check whatever the records you are trying to insert is in the order or not. If it is they are not there in the order, it will physically rearrange the data in a particular order and it will load. Okay, so because I have created only one cluster index, that's why it is arranging the data in a ascending order on S number. Suppose if the system allows to create one more cluster index on this table, then when I run this, when I am trying to insert the data, in which order the SQL engine has to order the data?
Ascending order.
Yeah, if I have a one cluster index, then ascending order on S number column. If I have a one more cluster index created on this table with the different column,
It will be confused, sir.
the system will not understand.
Yes, sir.
So that's the reason why. So we can be able to create only one cluster index on a table. Okay. That cluster index can be created on multiple columns. Create on multiple columns. It's called composite clustered index. Composite clustered index. Okay. So D. I'll show you how you can create a cluster index on multiple columns. Same, nothing, same. You can, this query is there, right? I am not creating now, but I'll show you. Same as name. Just keep the multiple columns. Okay, when you are keeping these columns, multiple columns, so the data will be arranged based on this granularity, both S number and S name. Okay, how order by will work? You remember, right? Order by, how order by will work? In the
Yes,
same
sir.
way,
Ascending order.
in the same way, the data will be stored. Okay, this will not required any separate storage. The cluster index will not require any separate storage. Why I am talking about separate storage is, see here, the cluster index is rearranging the data and storing it. Where it is storing? Is it storing in a different table or in the same table?
Same table.
Same table. If the data is in a proper order and not in a proper order, will it make any difference in the storage?
No, sir.
No, right? So only this will help us in increasing the performance. That's it. The data from the data storage point of view, it doesn't require, it doesn't occupy. If you create a cluster index, it doesn't occupy any extra space. Whatever the space that was allocated for this table, data from this table, and in the same storage space, it will load the data in a proper order. That is only the difference. That's why I'm mentioning this will not require any separate storage.
So, sir, if we can only S number or only one value, sir.
Sorry.
అంటే ఇప్పుడు మనం ఏదన్నా ఒక వాల్యూనే ఇండెక్స్ లో తీసుకోగలమా?
లేదండి, మల్టిపుల్ కాలమ్స్ కూడా క్రియేట్ చేయొచ్చు. యూ కెన్ క్రియేట్ ఇండెక్స్ ఆన్ మల్టిపుల్ కాలమ్స్ యాజ్ వెల్, క్లస్టర్ ఇండెక్స్. But the thing is, only one cluster index can be created. So you know, right? So primary key can be created on only one primary key created on a table.
Yes, sir.
Yes, sir.
And the primary key can be created on a multiple columns. In the same way, only one cluster indexes can be created on a table. Okay? That cluster index can be created on multiple columns. Okay? One more thing you need to remember is, if you create a primary key on a table, if you create a primary key on a table, automatically cluster index will be created. Automatically, the cluster index will be created. Okay?
Okay, sir.
So, next, non-cluster index.
Sir, I have a doubt, sir.
మనము
ఇందాడ ఎస్ నెంబర్ కి క్లస్టర్ ఇండెక్స్ ఇచ్చాం కదా సార్. సో నంబర్స్ ఉన్నాయి కాబట్టి నంబర్ సార్ట్ చేసుకుంది సార్, 1 2 3 అలాగా. అదే నేను ఎస్ నేమ్ కి ఇస్తే ఆల్ఫాబెటికల్ గా సార్ట్ చేసుకుంటుందా సార్?
ఎస్ నెంబర్ అండ్ ఎస్ నేమ్ బోత్ కాంబినేషన్ లో సార్ట్ చేసుకుంటదండి.
నేను ఓన్లీ ఎస్ నేమ్ ఒకటే ఇచ్చాను సార్, నంబర్
ఆల్ఫాబెట్స్ లో స్టార్ట్ చేసుకుంటది.
సో ఏ ఉండే లెటర్స్ అన్ని ఫస్ట్ సార్ట్ చేసుకుంటుంది
అంతే.
ఓకే సార్.
ఓకే. నాన్ క్లస్టర్డ్ ఇండెక్స్. ఓకే, ఇట్ విల్ stored as a separate database object. So how it is so it will be stored as a separate database object. So manaki book lo, in the book we will be having an index as a separate, right, as a separate page.
Yes,
in the index, what are all we have?
Chapters,
chapter name, topic. So chapter in the sense the topics and the page number. So here also, whatever the columns that you are you have created a non-cluster index. Along with that columns, all the columns, along with that columns, there will be a index key. So see, when you create a cluster index on a table, the data will be there in the same page, same table. It will not be stored in anywhere. But when create a cluster index, so actual data will be there in the same table. Okay. Suppose I have an employee table. Okay. In the an employee table is there. So it will store the data in the database, right? So that data will be there. When you are creating a non-cluster index on that table, so it will on whatever the column that we are using in that non-cluster index, with that columns, it will create a one more object, which means the data will be there as well. Let me show you. Suppose I am just creating a create index ix underscore empid, okay, on employee of s number, sorry, empid. So here I am just creating a non-clustered index on employee ID column. So what it will do is the employee table will be there as it is, and there will be a one more object created with reference to this name. Okay, with what information? Employee ID and index key. Employee ID and index key. It will create a separate database object, but there will be a relation. So this index key is there, right? Index key knows where exactly that data is resides. This
Yes,
index
sir.
key knows where exactly the data resides. Okay, that's why. So what I'm saying is it will store as a separate database object. Okay. Multiple non-clustered indexes will be created on a table. You can create multiple non-clustered indexes. Okay. This will occupy separate storage. This will occupy a separate storage. So why it will occupy a separate storage? Because whatever the columns that you are using to create a non-clustered index is storing it as a separate database object. Object in the sense it's a one table will create. Object is nothing but objects in the SQL server are like tables, views. Okay, tables, views, procedures, functions, triggers. These are all the objects in the SQL server. Not only in the SQL server, in Oracle also we call them as objects. Okay. Okay. Syntax to create clustered index. Okay. Create clustered index name on table name of column list. Okay. Syntax to create the non-clustered index. So simple. The same thing. Remove the keyword cluster. That's it. This is the non-clustered index. Okay. So have told you the clustered index and non-clustered index. Okay. Okay. So I'm just saying that when you are checking the estimated executed plan, you have seen if you created a cluster index and a table that is performing a index scan or index seek. So how it is performed and how the searching will be. So by default, indexes will use balance tree method. Balance tree method. You can call it as B tree. This is some algorithm. Okay. Balance tree method. What it will do is, suppose an example, and so I have one document, and on the document I will show you. I will share this document. as well. See here, I just wanted to not this. I can let me go. Oh, yeah. This is the document. Okay. Okay. So first, before going this, let me explain the above. Right. So in the let us assume I have a table with 50 records. I have a table with 50 records. Now I want to search for the 50th record, and I don't have the indexes created on my table. Then how many searches will happen to get the 50th record?
49.
49 records.
50 is 50, right? 49 record, 50. So it will do 50 searches
Okay.
to get the 50th record. Okay. It will go one by one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, like that. It will go record by record until the table reaches its last record. Okay. So if I create a clustered index, so if here we have a 50 records only, so as I said, since the table that we are using, employee table, has only 14 records, so it is giving a faster result. But if in case we have a large number of records, volumes of data, so it will become messy, right?
Yes, sir.
That's why so then definitely we need to look after for increasing the performance. So the concept called, as I explained you, the clustered index. Okay. So when we create a clustered index on a table, an index on some columns of a table in SQL Server, then what happens internally is it creates a B tree structure. In the B tree structure, the data is divided into 3 sections. In B tree structure, whatever the data that we have will be divided into 3 sections, which is root node and intermediate node and leaf node. So every table will be having, every index will be having one root node and one leaf node. The top one we call it as a root node, and the last one is we call it as a leaf node, and whatever is there between a root node and leaf node, we'll call it as a intermediate levels. The data will be split into multiple intermediate levels. Okay, how it would be. So in our example, we have only 50 records. So in the 50 records, in the root node, what the root node has? 30 and 50. So when it comes to the non-leaf nodes, this is the intermediate level, you can call it as. So what will happen is our SQL engine will come to the root node first. SQL engine will come to the root node. And what is the value that you are searching for?
50.
50. Either 50 is less than 30 or not, it will check. Is this 50 less than 30?
No.
No, right? And then it will go and search for the second value. Is 50 less than or equals to 50 or not?
Yes, sir.
So by checking a one condition, it is bypassing all these 30 records or not? See, if it is the number that you are searching for is in within 30, then it will go to this. Since it is not 30, how many records it is bypassing? See, you are searching for 50, right? These are all the records. These 2 records are bypassed. And then it is going to the leaf node, non-leaf node. And 50 is less than or equals to 40?
No.
No. Then this record, whatever the records under this non-leaf node also will be bypassed. And next it will go to here. And 50 is less than or equals to 50? Yes. So whatever the data that is under this leaf node, these 10 records, it will only scan these 10 records and it will provide us the result.
Sir, can you tell how the root node took 30 and 50?
So it based on the data which is available. See, in the employee number we have, right? Employee number, let's say I have 1, 2, 3, 4, 5, like 20. Okay. 20 employee days are there. So 10, 1 to 10 and 11 to 20. Root node. And in 1 to 10, if you come to the non-leaf node, 1 to 5 and 6 to 10. And in the other non-leaf node, 11 to 15 and 16 to 20. So based on the data that we have available, that cluster index, the B tree structure will be formed with the root node and intermediate levels and the leaf nodes. Leaf node has the actual data. Internally, it will perform only. We don't have anywhere to check what are the values available in the root node. Okay, general example, I'm just explaining you how internally the search will perform when you are creating an index on a table.
Okay.
Okay, so I have told you, right, when it is if you are not creating a table, sorry, if you are not creating index on a table, so it is performing a table scan and it is reading scan through all the records. Okay, that is true. And when I say when you create an index, it is not scanning through all the records. So how it is skipping the rows? You want to know, right? This is how it is skipping the rows and performing a search faster.
Okay, sir.
Okay. See here, it is not reading all the 50 records. It is just reading 10 records and it is skipping 30 records. Okay. This is. Okay. Next. How to drop an index. Okay. Just you can use drop index name, whatever you have created, ix underscore CLI underscore EMP underscore ID. Drop index name on this index we created on what table? Employee table. See, the index was dropped. Okay. అర్థమైందండి ఇండెక్స్ ఎలా పర్ఫార్మెన్స్ ఇంక్రీజ్ చేస్తాయో. Okay.
Just one question. What is the use of non-clustered index?
See, if you are, the cluster index can be created on only one column. And suppose if you are generally in where class, you will be using multiple columns in the where class for filtering the data. So it is not possible to you create one more cluster index. Then what you will do? You will create a non-cluster indexes on those columns. Okay. So what you will do is cluster index on which columns you preferably create is. So suppose if you are keep on loading the data, daily. So preferably you'll create an index on the date, so that all the data in a SQL server will be, so in the table will be in a particular order on a date. Suppose in that same table you will be having a one more column you will be frequently using in your joins. Then take that column and date column. The data will be properly arranged, and then the remaining columns you can create a non-clustered index. So what is the difference is, so then when you create a non-clustered index, what will happen is, first it will go to the index table. When you are using non-clustered indexed column in your where class, it will not directly go to the table. What it will do is, it will go to the indexed table, and there it will search for that value in the table, and whatever is there against that, whatever the index key is against that value, it will take that index key and it will come to the actual table and it will pick that record and it will give it to you. The same way how it will work is like how it will work like is general our indexes in book. Suppose if I ask you to search for a topic, what you will do? You will directly go to the index page and you will search for that topic, and whatever the page number against the topic, it will take, you will take and you will go to that page and it will take your information. Here also the same. When you are using non-clustered indexed column in your where class, that will directly go to the index table. And index table, suppose if you are doing select start from EMP where employee EMP ID equals to some number. Okay. assume that you have created a non-cluster index on that employee ID. Guys, please mute yourself. Okay, non-cluster index. So whatever the value that employee ID has in the index table, it will search for that value. Okay, as soon as it finds that value, and against that value, whatever the key, index key is there, it will take that index key and it will come to the employee table and it will extract that record. It will extract that record. Suppose whatever the non-cluster index you create on the table, already cluster index is also created, then it will perform the same. I have shown you, right? If you create a non-cluster index on the indexed cluster indexed table, then it will perform same. If you create a non-cluster index on non-clustered indexed table, then it will go to the indexed table. It will be quite confusing here. Suppose if you create a table without creating an index is heap table. Okay. If you create an index on the table, then we call the table as a indexed table. Okay. So on the table, we can create either clustered index or non-clustered index, or you can create both. Okay. If we create a cluster index on the table, and if you are querying the data using clustered indexed column, the search engine will be it will perform the search engine like this. Okay. How the balanced tree structure is this. Suppose if you create non-clustered index on the clustered index table, okay, then also it will perform the such operation will be like the same. Suppose if you are creating only non-clustered index on a table, then when you search for a data, that will go to the indexed table, and it will take the key against the value, indexed key against the value, and it will directly go to the actual table and it will retrieve the data. This is what the difference between heap table, cluster index table, and non-clustered index.
Yeah, Krishna. Hello.
Yeah, Chapan.
Could you please explain non-cluster index with example once?
సేమ్ అండి నాన్ క్లస్టర్ ఇండెక్స్ కూడా సేమ్ ఇలానే క్రియేట్ చేస్తాం అంతే. ఇది ఇక్కడ ఉంది కదా థింగ్ చేంజ్. సో ఇక్కడ ఎంప్లాయీ టేబుల్ ఇది ఉంది కదా. సో దిస్ ఇస్ క్లస్టర్ ఇండెక్స్ ఆన్ ఇండెక్స్ క్రియేటెడ్, నాన్ క్లస్టర్ ఇండెక్స్ క్రియేటెడ్. దట్స్ ఇట్. సో this can't be physically explained, so I am just explaining you how internally it will search.
Okay.
Suppose on this table, suppose I am doing on employee ID only I did, right? Suppose let's say I am just dropping. So on this table, on this column, let me do one thing. Drop index.
Sir, can you clear the screen? Someone has painted on the screen.
Yeah, there's like too many lines on the screen, Krishna.
How can I erase it here? Do you have any options over here? Can I close and relog in?
No, Krishna, can you check the top of the screen?
I'm not seeing any options here. This one. Erases. Okay. Okay. Let me drop index. Okay, this is an employee table, right? Okay. Let's create index Select star from temp. Okay, where s number equals to 1. Just check what we are getting. Index seek, as we discussed. Okay, and if I do s name equals to Krishna. Okay, do you have any records with this? Yes, I have record. So search it.
Scan.
What is performing? Scan. So here what I am doing is create index ix underscore s name on temp of s name. I am creating a non-clustered index on
Clustered
clustered
index.
table. I am creating a non-clustered index on clustered table. So what it will, how it will perform is, see what happened now.
Index seek.
Earlier what it is?
Clustered index scan.
Clustered index scan. So now I have created a non-clustered index on the clustered table. Got it? It has gone to index seek. Suppose, okay. Now I am dropping a clustered index. Okay. ix underscore s number on temp. I'm just dropping a cluster index. Okay. Now see. What it is performing? It is performing, though you have created a non-cluster index, it is performing table scan only.
Table scan.
Okay, it's not seek. But how many reads it is performing? 5 reads it is happening.
5.
Okay. Create index. Yes, name. It is there, right? Yes. Yes, name. This is already there. If you want to check sp underscore help index. So this you can't use this temporary tables. Forgot. So if you want to check this temp table, so we have these are available in the system databases. In the temp DB, temporary tables will be stored in the temp database. And tables. Yes. Tables, see here. This is the temp table we have created. So if you want to check the indexes, it is not possible to check unless it is a physical table. Just trying to see. This is what estimated executed time. This is what include actual execution time. This is library statics. So if you run this query, if I check it in the messages, let me include actual execution time. This is the execution plan. See, it is performing an execution plan. See, after execution of a query also, you can see the execution plan for this query. Which execution plan, which plan it has used. So it has used table scan. Okay, so it is reading number of rows read is 5 and actual number of rows for all executions is 1. Okay, suppose if you create an index cluster index on the table, it is doing index seek. Actually, when I am creating a cluster index on this name index it should use scan, but I'm just checking why it is not using. It should use at least index scan. Let me create index on ix comma number. Okay. These tables can. Is performing table scan only. Here.
Just one doubt. In the table scan, what is the cost is equal to 100%?
This is a optimize. See, when you are executing a query, SQL will be having a two types of optimizer. One is a rule based optimizer, and the other one is a cost based optimizer. Okay, so when you are performing a updates or deletions or something kind of things, so the cost of database is more when you are performing updates, because when you are doing an update, what will happen is internally it will delete the data and reload with the insert a new record with the latest changes. But we'll simply know what the update will do is it will simply replace the old value with new value. But internally what happens is it will delete the entire record, old record, and it will keep somewhere, and it will take all the values except this, and it will insert a new record, entire new record it will insert. So deletion and insertion is happening, right? So that's why the update is costly in the sense it will something. If you are purchasing a database, the servers in the real time, the servers will be purchasing database and all. So when you are building this, those operations will be costlier operations. Suppose if you go to the cloud versions, so whatever the storage that you are using, that much only you should pay. So whatever the queries that you are running, and based on the resource and based on the scale and based on the amount of data that you are processing, the billing would be varied. Okay. This I will check and let you know, guys. One thing what we need to for is, though you created a non-cluster index, it should perform an index scan as per my knowledge. So I'll check whether the what we are getting is correct, or do we need to make any changes to this. I'll check and I'll let you know tomorrow. In tomorrow's class, we'll discuss this, and the next topic we are left with is procedures. SQL stored procedures, and tomorrow is our last class. Okay.
Sir, I have a doubt.
చెప్పండి.
మనం ఒక కాలం మీద ఇండెక్స్ క్రియేట్ చేసాం కదా సార్,
అవునండి.
నేను ఆ కాలం ని డ్రాప్ చేయొచ్చా సార్ వితౌట్ డిలీటింగ్ ఇండెక్స్?
No, it depends. See, ఇప్పుడు క్లస్టర్ ఇండెక్స్, సో క్లస్టర్ ఇండెక్స్ రిఫర్ చేస్తుంది కాబట్టి పాసిబుల్ and first you need to delete the cluster index, then you can drop the column. And suppose if you want to, if that cluster index is created as a part of your primary key constraint, then you can't even drop the cluster index as well. You want to, so if the cluster index is created by you, then that can be dropped. If that cluster index is created as a part of primary key, then you can't drop this cluster index. What you need to do is you need to drop the primary key constraint, then you can drop the cluster index.
Okay.
Okay, any questions? And
can you share today's index PPT?
This whatever I explained, or you are asking this document?
No, that document, sir.
No, this I will share it.
Okay, thank you.
Okay, explain complete will be there, and you can go through it. Okay. Okay, guys. Thank you. If anyone has any doubts, you can ask me. Okay, guys. Thank you.
Thank you, sir.
Thank you, Krishna.
Let me share this document right away without further. Without,
ఆయన ఎప్పుడే వాడిని ఈయన లైనప్ లో పోతాడు ఈయన పక్కనే ఉండొచ్చుగా ఇన్ని మిస్టేక్స్ అంట వాము ఏం పెట్టారు నేర్చుకుంటారా
okay. So share. This I will play it.
హలో హలో ఇది మన డిఎంఎస్ ఇన్సెట్స్ పంపించాం కదా అందులో ఒక ఎర్రర్ ఉందంట ఐ రోల్ బ్యాక్ దిస్ టైమ్ అని చెప్పేసి
I will share the video in some time. And
ఏంటి యూజర్ ఇంపోర్ట్